Hello again, this is Dirk Strobe speaking from the Information Lab in Germany. Welcome again to our last Tableau Zen Master webinar of the year 2017. Well, thank you for being our guest today. With me today is Craig Bloodworth from the Information Lab in UK, a long-lasting Tableau Zen Master. He has been Zen Master for years already, with deep knowledge about all, well, I would say all products of Tableau itself, if it comes to Tableau Desktop or Tableau Server, also in regards to, well, mapping, which is going to be the topic for today's Zen Master webinar, the future of Tableau mapping. Some words about the Information Lab, just quickly. You can see a map of the UK here on the screen, hopefully. Craig is sharing his screen. You see the UK there, but the Information Lab group is actually working across Europe from different locations. I'm not going to name all of them, but for instance, we are covering Germany, France, Netherlands, as well as Italy, Poland, and Ireland. I may have forgotten one or the other, but we are in business in all of these countries, helping support Tableau customers, our customers, not only Tableau, also Alteryx customers, or organizations who actually want to improve the way they're working with data in general, implementing a proper state-of-the-art analytics culture. We have reached around 250 attendees now, which is great. Thank you very much for joining today. I can already announce that we're going to go ahead with the Zen Master sessions next year on a monthly basis, most probably. So that's the great news, and you will receive an invite for the next sessions in 2018 fairly soon. Looking forward to that. Last organizational thing I want to mention, we are going to have a Q&A at the end of the webinar. So you can use the Q&A panel you will see on your screen to raise your question, and Craig is going to answer hopefully all of them during the call. Otherwise, we will collect them and send a response and answer afterwards. So at this point, thank you very much. And I want to pass over to Craig Bloodworth, Tableau Zen Master from the Information Lab in UK. Craig, your turn.
Hey everyone, thanks Dirk. So yes, add my thanks to joining this morning. I have sort of one little bit of admin to add, and that is that, you know, it's getting into winter. I'm deep in the throes of an awesome cold. So if all of a sudden the mic goes on mute, it's because I've, you know, got some coughing to do, and I don't want to blow your eardrums with your headphones on. So do bear with me if I suddenly go quiet. So for the next sort of 40 minutes or so, we're going to talk about Tableau and the future of mapping within Tableau. To start with, I'm going to sort of go into a little bit of past, the history of sort of where maps have come in the past 5 years with Tableau, from the first start up until today. We'll look at how Tableau is enabling everyone to be a specialist in mapping, how just they're making things easier with every release, and allowing people to be, you know, GIS experts, but able to do lots of stuff with mapping in Tableau. We'll look at how once, you know, we've got mapping data, we've got geographic data, we can share it around, and the options that are coming open in there. We'll look at how all of this comes together in sort of the Tableau as a platform, which we're hearing about sort of more and more from Tableau, and how the mapping space fits in, or an example, a case study of how I've been able to implement Tableau very nicely as sort of this platform within mapping. We'll sort of conclude looking at my sort of look over the horizon, where sort of some features and functions that I would love to see come in to Tableau mapping. And then, as Dirk says, we'll finish with some questions. Don't hold the question sort of right until the end. Feel free to stick it in the questions panel, and we'll get to them all right at the end of the presentation. So let's kick off now. The history of mapping in Tableau. It sort of breaks into a few sort of key areas. Looking at the background layer with it, the thing that makes a map look like a map. How that's been delivered in terms of mapping servers and where they've come from and where they are now. And then things that Tableau are doing to make that even better with their integration of Mapbox. So first of all, what is a map in Tableau? If you don't know or you haven't sort of thought about how Tableau's maybe drawing maps, it is simply a scatter plot that's been sort of twisted a little bit to make it fit the scale of that a map is normally shown at. And then it has a background put behind it. And really a map, as you can sort of see in the top left of the screen there, is three different layers. The foreground layer is the bit that we interact with. This is the dots, the polygons, whatever it might be, same as it would be a bar chart or a line chart. And then really there's the background part of the map, which is broken into I like to think two different areas. One is the background base. So this is usually sort of an indication of where land is, where sea is, where water is. And then on top of that, we then layer on various elements. And if you've come across the map layers menu in Tableau Desktop, you'll have seen the list of all those different layers that you can add, things like streets, place names, boundaries, anything you want, so you can have a map as simple as you'd like, where all the data stands out, or you can have the map as complex as you like, where you've got lots of rich information in that background map to help sort of explain why the data is positioned the way it is. Now, when Tableau started up with mapping, when they brought the feature in, they needed someone to provide all these background images. Providing a map, a global map, is quite a big thing to do. It's lots of data that need to be processed, lots of images that need to be rendered. And so Tableau reached out to a third-party mapping service called Urban Mapping, who provided all those background maps originally, sort of about 6 or 7 years ago. They did have a way to sort of bring in a little bit of customization with the background map. The only way was third-party integration through something known as a WMS, a web map service. And while that was okay, creating a web map service was a headache. Having to, if you could find one that you could use, it was sort of stretched in a weird way. It's not the projection, the sort of way to display a map that people are used to in terms of, everyone loves to use Google Maps, and it has a very set projection, and WMS always came through as a very strange way. So it sort of wasn't a natural way to customize the map. People didn't really like it too much. And there was a few of us in the Tableau community who decided to try and fix this way back when by breaking apart something called a TMS file, a Tableau Map Service file. It was actually a really sort of most hackable part of Tableau mapping, because you could point it at any map service that you want to. You could customize all the layers that went in there, and someone's got a bit of a name for producing these TMS files that could do lots of funky stuff. The reason we had to sort of do that, the reason we spent lots of time doing it, is because the maps back from Urban Mapping were slow, especially outside of the US. They were very low on detail, and if you zoomed in too far, quite often you found yourself just getting sort of blank maps and blank map tiles. It just wasn't a really great experience. So a couple of years later, Tableau builds its own map servers. They reached out to another company, but just to do the design work this time, a company called Stamen Designs, who specialize in creating maps, the sort of cartography experts, and they know how to style maps in a certain way. And they created the 3 styles for Tableau to help represent data in a way that gives that background context of a map, but doesn't sort of get in the way of the data. It's no surprise that the light design is default in Tableau. Okay, so a nice gray map in the background allows the data to pop with, you know, as little detail as needed, just to make sure that you know where you are in the world. And the dark map of, you know, if you've got, it tends to be sort of quite a dark subject. If you're creating a dashboard that has that era of sort of feeling a bit dark and a little bit menacing, the dark map is a fantastic way to you know, keep that theme going. You don't want to create a really dark dashboard and then have you know, this bright light gray map. So those 3 map designs are available now, and part of that, the thing that allowed Tableau to create these 3 themes exactly how they wanted to, was by building their own map servers. They own all of the data that it comes through into that background map. They get it from OpenStreetMap, and it's all, you know, developed every quarter. They're coming out with more and more data, getting more data into the servers. The servers are also distributed around the world, so hopefully globally people get a better experience with mapping. And you know, it's no surprise, put in the top right an example here, I think it's from 10.4, the, you know, map updates have become a part of the Tableau release. Every single release that comes out, every dot release, includes some form of mapping update. Okay, this time this example is that they've sort of got all cities in the US into their mapping data regardless of population. And this is just a theme that's continued over and over again. So, you know, Tableau a few years ago, building their own map servers, taking ownership of that data, developing that data. It's not just allowed us to use great background maps, but it's also helped Tableau develop the inbuilt geocoding and just make it better and better and better. So that, you know, when you have a bit of geocodable data within your data set, it's just automatic, and you can display a map if you want to. And so the final thing in the history of maps sort of comes as a result from hacking those TMS files, those Tableau Map Service files. It's Tableau kind of recognized that while they have these 3 great designs, people will want to do more. They'll want to put more into that background map. They'll want to customize it exactly how they want to. And one of probably the best platforms on the market right now for doing that is Mapbox. And so Tableau reached out and integrated Mapbox quite deeply into the mapping function. So you can go on Mapbox's website, you can create yourself a free account, you can start their online in-browser studio editor, and you can choose a map to go, you know, a template to go start with, or start completely fresh and use all that OpenStreetMap data and customize it and make it look exactly how you want to in the background. In the example I have here, I've not just taken a background map, a standard background map, and sort of stripped out all the roads and things, but then I've also added the UK rail network. So, you know, we can create like a visualization about the UK railways. And if this is something that, you know, you want to go on and do, this is something that's of interest to you, I would suggest that you Google Tableau Ultimate Mapping Guide, as myself and Chris Toomey, who as of a few weeks ago, I believe, started working for Mapbox. We created a 5-part guide on creating custom maps for Tableau using Mapbox. So by all means, have a read of that and get creative. So that brings us up to today. Quick way. So today I find that Tableau, you know, it's on this march to make everyone a specialist, make everyone more capable, and you know, mapping is a big part of that. And three ways I want to highlight that Tableau is doing this is, first of all, with the spatial file connectors. So you can connect directly to spatial files local on your machine without having to do any conversion. The spatial data type that came in hand with that. So you'll see some brand new measure pop up occasionally called geometry, and we'll take a look at an example of that, and also an example of how to use that with something that hasn't come into Tableau yet, but is on its way and was demoed at their conference in Vegas, the Spatial Join, and we'll go through an example of how I think sort of that can help your analysis. So for anyone who hasn't experimented with or used the spatial file connector, I just wanted to highlight that since Tableau 10.2, there's native support for ESRI shapefiles, GeoJSON, KML files, and map info. If you do sort of want to Google to find boundaries or election districts or counties or something like this, chances are it'll come from a government source, and chances are it will be in shapefile format. So it's great that Tableau now supports this natively. You can also create your own shapefiles if you have some software that will produce them, and just use them straight away directly in Tableau. So if you have some, say, custom sales territories, then you can just make use of that shapefile connector. And really what all of this did was it took away the need to create what I sort of call join the dot datasets. And this is the need that I had a couple of years ago before the shapefile connector came in, was all of this mapping data exists out there. It's not built into Tableau, but I wanted to make use of it. So I had to sort of take these shapefiles, I had to break them apart into the component latitude, longitudes, and then use the polygon mark type in Tableau to draw the shapes of whatever it was, the counties or the parliamentary constituencies or whatever it was, in a sort of join the dot fashion. And while I kind of worked and you could create the visualization that you wanted to, it did sort of have the negative effect of creating big, long data sets. Okay, geometries, polygons can have thousands and thousands of data points in them. And so, you'd take a shapefile that might have, say, 100 different areas and explode it into 100,000 or even 1 million records just to create one single map. And what did that look like? So on the left, you'll see the old method that I had to do when creating this join the dots data set. You would probably see something called a path in the file, and a polygon ID and a sub-polygon ID. Latitude and longitude would be their own measures. They wouldn't be the generated ones. And this tended to cause confusion. People would use the generated ones instead, or they'd use maybe the custom latitude and the generated longitude, and sort of get in a bit of a mess in trying to create this map. You'd also have to use something called the polygon mark type, which isn't something that people come across very often. And generally just wasn't a great solution for creating a filled map with data that is readily available. So on the right, you'll see how that changes with the introduction of this geometry data type. You can see at towards the bottom under measures, there is this new, it is a blue pill, but it is a measure. The reason for it being a measure is because it's kind of it's an aggregation of all those latitude and longitudes to form a polygon. And it really just has two steps to make use of it. The first one is to double click geometry. That brings out the generated latitude longitude. And then you need something that then splits all of those polygons into their separate components. And in this case, I used a dimension called nuts ID. It's from it's a European mapping data set at various levels called nuts, and it has an ID field that separates out all those polygons. So the spatial data type just makes Tableau mapping much more simple and user-friendly. And then we come to the spatial join. Now, Tableau demoed this, introduced it in the conference in Vegas, and it's really sort of their first ever spatial function that they've released, the Intersect function. It basically allows us to take points. So let's say, an example we're going to go through, locations of supermarkets, where it's one building, it's a single point, otherwise known as a centroid, and then overlay on top of that some areas. So again, in the example, we're going to look at postcode areas, and sometimes, or quite often in spatial data sets, there isn't really a way to link two data sets together. Okay, if you're lucky enough, then the my supermarket's data would have postcodes in it, and I could maybe try and join based on that postcode. But lots of times, of course, postcodes don't get populated, or they're just messy, or they're incorrect. But we have something that's very accurate. We have the latitude, longitude of that point, and so the intersect join allows us to connect those two together, just basically on their physical location. And this is very powerful. This allows us to do bring mapping, not just into Tableau as a visualization, but also as a way to pull data sets together, enhance data sets, and answer more questions. So let's take a look at a demo of how I might use that. I'm going to start with a little introduction of the data and generally sort of why we're talking about this. So in the UK over the past few years, there's been lots of news about this this influx of two discount supermarket chains from Germany, Aldi and Lidl. And it's really sort of been a story about how the top 4 supermarkets in the UK, and most notably Tesco, at least Tesco always seem to get in the news about it a lot, how they're losing out market share year on year on year. And you can see quite clearly in the data here, we have the top 4 supermarkets. This is the 12 weeks leading up to September, 10th of September this year, 11th September last year. And you can see that, quite clearly their market share has dropped, and Aldi and Lidl have picked up a greater market share. And this is data from Kantar's consumer data set. So why is this? Are Aldi and Lidl, just blitzing the whole country? Are they just really good at selling from a very few stores? Is there some sort of strategy maybe they have to rolling out across the UK? Obviously, these Tesco has a lot of coverage in the UK. Stores are in lots of locations. How maybe are they going about picking where in the UK to put those stores? So to answer that, I have a few different data sets. I have the location of Aldi stores, I have the location of Lidl stores, and I have the location of Tesco stores. Just to show you what the Tesco store looks like, I'm going to connect to this spatial file. We'll go to my Tesco locations, and this spatial file is in the form of a shapefile. Okay, if you haven't come across a shapefile before, it's pretty clear when you've downloaded a shapefile and you've unzipped it. First of all, it has the extension .shp, and then also there are 3 other files at least. Sometimes there are 4, sometimes there are 5, and they just basically describe different elements of the geospatial data. So if I go ahead and open this shapefile, we'll see that it's really pretty simple. There are only two columns. One is an ID field. Okay, this is taken from OpenStreetMap, so this is the node ID of all of those Tesco stores. And then we have this new geometry data type, right? And we can see that these are point locations. Right now, what Tableau has actually got in here in the background is it's hiding some data. For a point location, it's hiding one latitude number and one longitude number, and it's representing that as a point. If it was a line or if it was a polygon, it would be lots of latitude longitudes in a certain order in order to draw that polyline or that polygon. If we bring up a new sheet and double click geometry, we'll see Tableau knows this is geographic data. It's pulled in all those points. One thing you might notice the first time you do this, you get a map, you think, oh, brilliant, I'm done. And then you go to hover over it and you're sort of a bit, wait a minute, why is it selecting everything? That's a bit weird. It's because this is an aggregation. It is all of the points all as one mark. And you can see that in the bottom left-hand corner, one mark, one row, one column. If you want to split it into all of its components, all of the single point locations, then you need a dimension to put on level of detail and to cut it into all of its individual points. Now you can see we have 1400 marks, and each of those is now selectable. Okay, so really using geometry data type is, yes, it's a one double click, but it does have sort of that second level action of choosing what level of detail to separate the points or the polygons into. Okay, so those are all the locations of Tesco. Now, what I'd really like to do is to assign these locations a postcode area. Okay, I'm going to be combining these and sort of analyzing to see, how many Tesco stores there are in an area versus how many little stores and how many Aldi stores. Now I could just sort of eyeball it. I could put all the points on one map and see, where the clusters are and everything. But wouldn't it just be better to sort of group them together into some sort of region and then go from there? Now, remember back in the data set, I don't really have anything to join by. I don't have a postcode in here, but I do have a latitude longitude in this geometry. So I can go ahead and connect to another spatial file. This time it's going to be my postcode locations. And this is an area of postcodes. Okay, so I'm going to go ahead and open that one. And we'll see Tableau has tried to do a join between the two. Just to sort of clarify there, when I was creating the connection, I didn't go up here and say new data source. That would create a completely new data source. Instead, I just went to the right of here, connections, and hit add, and added a connection in so that I now can put these two spatial files into one single connection. I can then pull down here and we'll see that, again, we don't have much data to work with. We just have the geometry, but I can make use of this new Intersect feature and join the two based on their location. Immediately we see down at the bottom, we've gone from no data to now pulling in, to now joining these two data sets together. There is some repetition in here because for each point in my Tesco data set, it will tag it with an area of that postcode. Okay, so we can see that these two stores belong in this one postcode area. Right, so it is a classic join. If there are one-to-many or many-to-many connections, then it will behave just like it would any other join. And we could now go in here and we could say color these by that postcode area. All right, so I'm not working with the polygons yet. I'm still working with the single locations, but I get to use that polygon. I've now tagged all of these stores by their postcode area. Okay, this is great. This is a good start. This is something that I can make use of. Now let's bring in some other data as well. I went ahead and built out the data set a little bit more using the exact same method, connecting to two other spatial files. One is for Aldi and one is for Lidl. dragged them out, and again did an intersect join between them. So now I have one extracted data set that has all of my locations for all of the stores, and they've all been tagged with the postcode area. I've also gone ahead and created a few calculations, which are basically just a count distinct of the ID field. Okay, so we can do a count of all the stores. Let's draw a map of the postcode area this time, and we'll see how we can make use of the count field. So we've now separated this into separate postcode areas. Okay, again, nice and easy. A couple of clicks and we're done. And then let's say do a count of Tesco stores. When the map updates, we then see that there are certain areas that the Tesco seem to have more stores in. Manchester seems to stand out as an area that they've focused on building out stores. Obviously London, a big collection of them down there, but also Glasgow and not too far behind Edinburgh. But while this is, I could go through and now I could create a map of where Lidl and where Aldi is. I don't have to necessarily create a map. Right? It's one of the things about mapping data. It doesn't always have to lead to a map. I can use the same data set and just create a regular bar chart because I want to know, where Aldi are compared to Tesco and Lidl around the country. A bar chart can be just as useful to do that. So let's have a look at all of those Tesco stores. All right, so Manchester is the top. And then let's have a look at, I've done a combination of Lidl and Aldi. I guess it would be called Lidl, because it's both of these stores that are taking market share away from Tesco. So let's look at them as a sort of one competitor that's coming into the market. Drag it out and we can see the difference between them there. So some areas have more Tesco. Well, most areas have more Tesco. In general, Tesco has been around longer. Okay, so they've established more stores. In occasion, they're sort of about on par with each other, but most of the time, Lidl and Aldi are both behind Tesco. So let's try and sort of fix that a little bit. Let's just do a sort of a percent of total across the country for each store. So we can see that, where have they put their resources? Okay, which areas of the country, given the difference of time that they've established in the UK, let's try and normalize it and see if we can figure out where across the country they're really sort of putting their resources. I'm also going to drag out mention names here, and you can see that the difference between now Tesco and Lidl and Aldi. Now, there is generally sort of a trend that emerges. In Manchester, almost exactly the same sort of, they've put just as much resources as each other into Manchester. Same for this, I don't know all the postcodes off the top of my head, but same for G, for PO, for B. In fact, Lidl and Aldi have overtaken in terms of they put more resources into those areas. But then, N, again, it's way down, SO, way down. And, there must be some strategy behind this. There must be a reason why this is happening. Well, let's put them together in a dashboard along with our original sort of Tesco location map. And I sort of hypothesized that maybe it's to do with the cost of property in those areas. And so let's test that. If we go to Manchester at the top, all right, just for people who aren't aware of the UK, this is where M is, all right, up in the northwest. And if we go to the average property prices, bear in mind, this isn't retail prices, this is including also, this is household prices, but it gives us an idea of how much property is in those areas. Manchester down sort of 73rd of 108. Okay, let's have a lock at around sort of Glasgow area. Again, way down. Sorry, it would be way down the bottom. We don't have property prices, it seems, for Scotland. PO is 52nd, okay, towards the bottom. B, sort of around Bristol, is down in 60th. Okay, so these areas where they're sort of matched in terms of resources, they're pretty low on the property price scale. If we go to SW, straight away is 5th. E is 17th, okay, at least the sort of top half. Down here, N is 8. SO, top 3rd. But we get this idea. W is 3rd in property prices. So maybe this is the method that Aldi and Lidl are using. They're trying to match Tesco in terms of where they're rolling out resources across the UK, but only doing it in regions where they don't have to put up a big upfront cost. All right, yes, Tesco can dominate in the expensive areas. They're happy for that. Go ahead. But they don't. In the end, they're a discount supermarket. Maybe the reason they're having such a great impact is because they're focusing on where people just want discount stores to be. So that's how we can use that spatial join, that intersect join, to pull two data sets together that don't have a natural sort of join in their data, but have geographic information in there, and then answer questions with a regular bar chart without having to draw a map necessarily. Just to sort of head off any questions, yes, the Intersect isn't available just yet. It's not in the 10.5 beta, but we should sort of expect it to come in probably Q1, Q2 next year. There is, if you reach out to Kent Martin on Twitter, he leads the GIS team in Tableau. He is looking for people who are interested in testing out the Intersect join. So if that is something that's really of interest to you, Kent Martin on Twitter, and he'll send you an invite to their pre-release. So we've got lots of interesting data in Tableau. Like I say, from 10.2, we've been natively able to bring in spatial data, but how do we go about sharing it? All right, we want to make everyone a star with GIS. We want everyone to make use of this really interesting data. Well, let's put it out to the rest of the organization, the rest of the world. How can we do that? Well, first of all, there's Tableau Server. When Tableau introduced native support for spatial files, it didn't just stop with Tableau Desktop. All right, in the end, it is part of the Tableau platform. It is, Tableau, whether it's desktop, whether it's online, whether it's server, can make use of this geospatial information. So one of the great ways you could share any spatial data that you find is using your Tableau server or your Tableau online account. Right? You don't necessarily have to put your business data in there. You could just share to the Tableau server, and then people can make use of those spatial files. Another feature that's going to come in soon, again, Kent's looking for people to test this, is Microsoft SQL Server with spatial data. Now, I did want to do a demo of this, but it turns out the driver, the ODBC driver for Mac, isn't quite there in terms of reading spatial data, so I have to wait for another time. But again, more sort of in the enterprise space, it is a great way to share spatial information. Now, this could be sort of your trade areas, your things that you're updating quite a lot, and you want people to use the latest polygons, the latest boundaries for where your sales happen. Or it could just be really useful stuff, right? It could just be postcode areas and counties and stuff like that. Things aren't native to Tableau, but people are going to use again and again. I do want to mention one of our partners, Alteryx, in the space, because this was kind of a weird thing for me. I'm using SQL Server for a long time. I don't think I've ever come across people with spatial data in their SQL Server. Maybe Tableau will change that. Now it's natively supporting it. People will reach out to it a bit more. So I didn't know where to get started. I didn't know how to get spatial data into SQL. Whatever you do not Google it and find yourself on a Microsoft help me page, because it is long, it is tedious, and it doesn't make any sense. And even if you do follow all the steps perfectly, it doesn't work either. The best way I've found to get spatial data into SQL Server is with Alteryx. Alteryx will natively just with two tools, an input tool to the spatial data and an output tool straight into ODBC with SQL. It will just save that spatial object file, and actually you could, if you can see on the screen, number 12 down there is asking, what the spatial object field is. All right, it'll just push it into Alteryx, and then Tableau will read it straight from there. Sorry, push it into SQL using Alteryx, and Tableau will just read it. All right, so if you want to blitz a bunch of spatial files, get them into SQL Server, download yourself a 14-day trial of Alteryx and give it a go. And hey, try some of the tools while you're at it. The third way to sort of really get spatial data shared around the community is with the Web Data Connector. Now, since 10.4, Tableau has supported the geometry data type within the Web Data Connector. For people who aren't familiar with the Web Data Connector, it is a connector that's been custom built by an enthusiast, a developer, whatever you want to call them. It's built in JavaScript. It's sort of web page enabled, and it tends to be web services and pulls data in from them and injects it directly into Tableau. It is worth mentioning, by the way, that while 10.4 is the official support for it in Windows, it seems there's been a bug for the first two releases. So the upcoming 10.4.2 is what we're looking for Mac to really make use of the geometry data type. So, where could you see data like this? Where could you see the geometry data type come in? Well, if you're using a Strava connector, using Runkeeper connector, Moves, Google Fit, all these things that you're mapping where you've been biking, where you've been running. It used to just be sort of a separate connection to bring in latitude, longitudes, and paths and all that kind of thing. Big long data sets again. With the geometry data type, it just becomes a native little thing that comes in with the connection. Pulling away from sort of the quantified self, again, we can look at Mapbox. Mapbox, as we're going to see in a bit, has a way to store geospatial data natively within its datasets API. And so we could use that to pull datasets in. Esri, same thing. They have a REST API where you could make calls to it to pull in the spatial data that you've saved in your Esri server. And with a Web Data Connector, that could come in natively within Tableau. So again, great ways to share spatial data and pull it in from various areas around the web. Now, Tableau is a platform. So all these things are great. All these features are great, but do they support Tableau as a platform? Do they form part of a generally greater need and a way to sort of make use of the best parts of Tableau, as well as the best parts of other things that you may use? And I want to sort of look at a use case. This is the update to Tableau Mapping WI, which is a repository for geospatial data for Tableau that I started about, I think, 5 years ago now, as a blog where you could download TDEs and you could manually build those polygons. As of last Friday, I pushed out the next version of it, which is a nice interactive map, which we'll see in a bit, and a way to search all of that data to find exactly what you want and then pull it into Tableau via the Web Data Connector. Why this makes great use case for Tableau being a platform is because it has to reach out to various different elements. After all, sort of a platform, a true platform, is, it's fantastic at the things that it's designed to do, but it should also recognize where it doesn't do things and should integrate with those seamlessly. And in the case of mapping, and in the case of what I needed to solve with this new version of Tableau Mapping WI, we're sharing geospatial data at scale with the Tableau community. Now, I could have used Tableau Server, as we've seen. I could have published data connections and have people connect to it, but trying to do that publicly has licensing implications. And then at a global scale, I probably only have one Tableau server, whereas obviously people want to use mapping data from around the world. And also, Tableau Server can't create spatial data. You have to sort of push spatial data into Tableau Server. It can't just create it on the fly as and when you want to. Mapbox can. So I wanted to reach out to Mapbox and see if I could integrate Tableau into it. So let's have a look at what the result of that was. Mapbox, like I say, has this datasets API, datasets repository that you can push geospatial data into. And this is what I did for various spatial datasets I could find from around the world, whether it be Italy, the US, Syria, Netherlands. Okay, so pulling in whatever data I could find and pushing it into Mapbox's datasets repository. Now, Mapbox has APIs, and I could connect my. Oops, this is going on pause. I could connect my my app, this new thing I was developing, this new Tableau Mapping WI web app, to Mapbox, and I could say, right, here's the name of the spatial data, here's the type, here's the country, and here's the ID from your API to go off and get the data set. Now, the result of that, when we look at when we log into Tableau Mapping WI, is we get a map, and this is now customized to where we are with all of that mapping data readily available. So I can go and choose, some data that I want to preview, let's say regions of France, and I can see not only the polygons that I'm going to eventually pull into Tableau, but also I can click and see a tooltip of the data that's behind them. All right, so I get some understanding of, is this the data that I'm looking for? Something I find though is even that for people is, they don't quite know what level, what layer. Obviously, each country has about 5 or 6 sort of boundary types by standard. So which one should you use? Well, there's now also a search within Tableau Mapping WI where we can find all elements that have York in the name, and we can then choose to just preview it, and it'll zoom into that particular area and show us the boundary that we're going to work with. So we can be sure, yep, this is the one that I want to make use of. Now, once we found the data that we want to make use of, we can then start up a web data connector, and we can do that by just hitting new connection, web data connector, and then typing in Tableau Mapping WI/WDC /web data connector, and it will pull in all of the data sets that are available, and this is just going to keep growing and growing and growing. And via the web data connector, we can pull in local authority district, as I've gone ahead and done here, and see not only the data behind it, but also this new geometry data type that then allows us to map the exact same map that we previewed in Tableau, and then do maybe a cross database join or a blend or something like that to visualize the data exactly how we want to with our nice sort of fairly native map. So I wasn't able to sort of share data easily specifically with Tableau, but I was able to reach out to other things and perfectly integrate it into the product. Now, to me, this forms the best part of what a platform should be. All right, it's pulling all of the best abilities of tools from around the web and allowing me to naturally and natively support them within the Tableau platform. Okay, so finally, looking at the horizon of where I would like to see Tableau mapping go and what I'm excited to come in the future. First off, more spatial joins. So we're seeing Intersect is the first spatial join within Tableau. There are a couple of others that sort of have slightly different nuance ways that they join data together. It contains, within, and touches. And then I'd also like to see not just sort of points and areas, but also being able to look to, is a line contained within an area? Do 2 polygons touch each other? Is one polygon within another polygon? And just allow us to sort of maybe answer more nuanced questions using different spatial join types. I'd also love to see Tableau do more sort of spatial aggregation. Okay, so we've seen one element of this. If you use the inbuilt geocoding in Tableau, you're able to select different regions, group them together, and then have them behave as though they are one single polygon. So in the example you can see on the screen, the UK, France, and Spain are all behaving like one polygon because they've all been grouped together. And then other areas of Europe are behaving as a separate polygon. Now, that would be lovely to make use of within spatial data coming from the Web Data Connector or from SQL Server, because it would then mean that you could make use of, say, postcode regions or sectors or whatever that you've downloaded from the web, and then create your own sort of custom on-the-fly sales territories, and then bring in different regions and see how that affects predicted sales values. And then finally, different spatial calculations. So that there is so much we can do with spatial data, so much that we can make use of to better understand and enhance our data sets, whether it's looking at the total area covered, the distance between 2 points without having to use some trigonometry that we've found in the Tableau community with just a native function, a bit like sort of the select tool that has the distance measurement on there, but being able to do it sort of directly in the data set. And like I say, those sort of join types, but also within spatial calculations. So things like contains and combine and touches within, and combine for doing spatial aggregation and making that a proper spatial calculation. I think this is something that Tableau, it'd be great if they get to work towards. It would answer quite a lot of spatial questions that people have. Okay, with that, I want to thank everyone for listening, and I think we've got sort of 5 minutes or so to go through any questions that anyone's populated the question panel. If you haven't, then this is sort of your last chance before the webinar finishes to get your question in, and anything that we don't get to, we'll make sure to follow up in an email afterwards.
Right. Well, thank you. Thank you so much, Craig. Great content you have been sharing today. Yeah, great. Thank you from Avinash as well. So a couple of questions we received, I think around 10. I guess we won't have enough time for that, but let's see. We're coming back to your questions via email then anyway. Jenny is actually asking if there's any way of incorporating polygons and points on the same map without having to use the background map to display the polygon.
Sure, AJ. So yeah, there is, you can do it within a single data set. It is a little hacky. There's two areas that it's not completely easy to do in Tableau like a one-click right now. I don't think they're that far away from doing it. There's two ways that I could see them doing it. The first one is to both support sort of multiple geometry types within one data set, so have both a point and a polygon within a single data set. And sort of what goes hand in hand with that is also maybe making use of the union function, so you could connect to separate spatial files and union them directly within Tableau. That's one way they could go. The other way they could go, which actually we have seen a demo of it at Tableau's conference, is allowing you to build multiple mark cards and actually do layering within the product. I don't think, as far as I've heard, that hasn't really moved on since the demo they did in Austin about 18 months ago. But that again, that is a way they could go. But yeah, it's not really sort of there in the product right now, although you can sort of hack something together.
All right, thank you. Another question, a bit of an unclarity if the intersect function is already implemented in 10.4 or going to be implemented in the one of the next versions.
So it's not in 10.4. It's not going to be in 10.5. It is going to be in whichever release comes in sort of Q1, Q2 next year. But like I say, if you are really keen to test it out and you want to sort of you've got some use cases for it, then reach out to Kent Martin on Twitter, and he will sort of hook you, or just email sort of your account manager at Tableau and say, can you put me in touch with Kent Martin, and he'll send you an invite to the pre-release so you can test it out yourself.
Great. Next question from Steve. Can we do maps with both area and point data at the same time?
Okay, so that's kind of the same question as before, combining points and polygons. Like I say, that there is a hacky way to do it, but no, it's not sort of natively supported right now. Tableau won't work with multiple geometry types within one spatial file.
Okay. Then Torsten got a question: how can I calculate the distance between zip codes and point it on a map?
So there is, for a while now, there's been a community post. If you just Google Tableau distance between latitude and longitudes, there's a I did as well as I could at maths at school, but still, sine, cos, and tan were never quite my thing. But there is a calculation that's on the web. It's been in the community for a long time that you can copy and paste out, and it allows you to do sort of as the crow flies, calculate distance calculations. But there isn't sort of a native spatial distance calculation right now. But like I had in my last slide there, I'm hopeful it's going to come soon.
All right, thank you. Another one from Torsten: how can I transfer an unknown map specification that he defined in the webbook in a new workbook?
Sorry, can you repeat that one?
How can I transfer an unknown map specification that he defined in one workbook in another workbook?
Okay, so repeating it didn't help that much. I'm going to Thornton, if we can, we maybe sort of connect with email, and we'll take that one offline, and maybe we can sort of build out that question a little bit more.
Yeah, perfect. That's fine. For everyone's information, we have recorded this session, of course, and we are going to place the recording on our YouTube channel. Alongside, we will share the slides, I think, and we can also share the data which you showed, Craig. Is that possible?
Yes, yeah, everything's public.
Okay, that's perfect. So you're going to receive an email from us latest tomorrow with a link to the recording on YouTube, plus additional information like the data and the workbooks as well. Renaud is asking, well, thanks for the great content. Where is the best place to get shape files? If not available as an open data source, are they hard to create?
So shape files are, you get sort of more success or less success in different countries. The UK is really good for it. There's if you Google UK Geoportal, there's a plethora of data sets available as shape files. They're covering every aspect of the UK. Europe tends to have pretty good coverage, different countries. Some of them tend to be locked down, some of them not so much. It really depends on where you're looking for, really. Of course, the best place to get all those data sets together and searchable and indexed and optimized is Tableau Mapping WI. So www.tableumapping.bi. Have a search for anything there. If you don't find what you're looking for, again, reach out to me on Twitter at Craig Bloodworth, and I'll do my best to find that data set for you and get it up there. I also welcome submissions for anyone who has data sets that they'd like to share as well.
Excellent. You actually started Tableau Mapping WI, right?
Yes,
Okay.
There's a blog that started about 5 years ago.
Perfect. Thank you. And another question, I think the last one for today, from Stephen. What is the performance of Spatial Intersect compared with Ultrix?
Oh, good question. So I haven't done any sort of real testing as of yet. It's in the end, the Spatial Connector with Tableau is under development. When it first released, it wasn't great. It did seem to be quite slow. I've been really happy with the performance in creating this demo. There doesn't seem to be much of a lag at all. You sort of notice an extra second or so for it to do the join, but not too much. It's really sort of how long's a piece of string. Like I said, depending on the complexity of the data, how many areas that you have. I'd need to play around with it a little bit more. One thing Tableau does have that might sort of make it a little bit faster than Alteryx is Hyper. So as far as I'm aware, Hyper is GIS enabled, so it does process GIS data natively, which means then it's doing it sort of all in memory, all this processing in memory. And so it could be, and it's newer, so it could be a little bit faster than Alteryx. But of course, Alteryx are working to make their product faster as well. So I don't have a great answer for you, but now you've asked that question, I think I might actually go and play and see if I can do some testing.
Lovely, good idea. Thank you. There are more questions actually coming in, but I think we're going to stop at this point. We're collecting them and go through them one by one, and we will be in contact with you to see if we can answer your questions on various points. Well, thank you for joining today's session for everyone. Thank you, Craig, for running through that great content today. As mentioned at the beginning of the webinar, we're going ahead with the webinar series next year as well. You can expect to receive further information on the dates and the topics and the speakers fairly soon, so latest in January, I'd say. And we will set up a full schedule for 2018, right? So you can actually select the webinar you're most interested in at the beginning of the year, and you will get automatic reminders for those, of course. Quick information about the data school. I think the data school is hiring at the moment. You may know the Information Lab is running its own data school in London, and there is the next cohort to start very soon. So you can actually apply to become a student at our data school. If you don't know what that is about, you can always check our website at thedataschool.co.uk. Looking forward to nice applications for the data school. Thank you, everyone. I wish you a very nice rest of the day or evening, wherever you are in the world. And thank you for being our guest today, and hope to see and hear you soon in 2018 latest. Thank you, everyone. Bye-bye.